3D printer video update. Okay, I think the last video I done on this printer was basically going through these linear bearings and these linear rods. As explained, they were purchased off of Banggood from China, and on first inspection they were not of the best of quality. More the rods than the bearings. The bearings are pretty standard and they're okay. They needed cleaning out, but they're fine. I've cleaned and polished the shafts, cleaned the bearings out, flushed the bearings, new grease. Yeah, they're still not great, but they do work okay. Now I've actually put them together. The action of this is actually reasonably good. There's no sticking points or any issues along the whole travel, so that's good. That worked out okay. I may replace the rods for some better quality ones, but first, yeah, I want to talk a bit more about the printer. I haven't really spoke about what my design ideas are, and yeah, so I just want to touch on that whilst I'm just sort of showing you where I am. I know there's not many people watching, there are maybe a couple, but I mean, this video is intentionally to show that you can just, you know, buy simple parts off the shelf, with some basic hand tools and not too much special material or anything, actually build a printer that's comparable to something like that. Now, this is the Axiom. It's a printer for high temperature, basically. It's got an enclosed chamber, ooh, glowing chamber. So yeah, it can stay warm inside. Okay, it's got auto leveling. Yeah, that's something I've thought about myself, but this is actually the first time I've seen this website. I've just gone looking for the Axiom just so I could put something on this video, really, and that's the first time I've actually seen that. But I was thinking about something similar because my design will would allow something like that with a slight modification to what I have in mind. But yeah, I mean, this is kind of what I've got in mind, the whole printer, really. I mean, mine's going to be Core XY, nothing special there. Yeah, well done. A high temperature head. Yes, I've got J3, I think, heads at the moment. That's not what I'm going to be using, obviously, not for the high temperature. I'm going to be modifying them quite considerably. I have parts started, a water cooling nozzle, in anticipation of once this frame and the mechanics is ready, I will hopefully have a nozzle ready to get up to 300 plus degrees. So yeah, that's something I'm working on at the minute separately. But back to this. I mean, this thing looks great as it is in US dollars, and here's a UK seller. Nothing wrong with the seller, nothing wrong with the printer. It's just the price. I mean, seriously? Okay, you know, it prints in high temperature polycarbonate, which it says it does, that's fine. But at the end of the day, the control board, the software, the firmware should I say, it is nothing really special. It's the same as everyone else is using. It's, you know, they've probably customized it a bit to suit themselves, but I mean, really, an aluminium frame, a skin, some doors, and just some basic mechanics, a high temperature head, a high temperature bed, and that's it. For how much? No. I bet I'll get this up to a hotter temperature than that will, and I'll easily match the resolution. And I'll do it for a lot less money, and so can anybody else, I think. But that's kind of what I'm hoping to Yeah, something like that, but mine's obviously bigger than that for a start. I've just gone big straight away. There's no point. I want to print some large objects, and I don't want to do it in pieces and assemble them later. I want to be able to do them in whole, and I don't want any messing around. This thing's going to print what I want, and I'm going to make it print what I want. And obviously there are printers out there that will print large polycarbonate objects, and yeah, so that's what this will do eventually. Yeah, still a long way to go. I appreciate I'm very behind, not as much done as what I was hoping to do, but basically what I have done is created a bulkhead, which is totally loose at the moment. I've had it back off since mounting it and fixing it, but yeah, once that is on tight, that is extremely rigid. It just locks this all together really, and it's only one skin so far. I will be extending the whole thing, because the plan may be to have everything behind an insulated barrier and keep all of this at a lower temperature. I'm not entirely sure yet. I may just insulate and skin this part, because the original idea of the bulkhead is, one, to give rigidity to the main core, but to also keep all the heat away from where all the hard, the electronics and controls going to be, and where all this lot's going to be. And these will not be anywhere down in here whatsoever. They will be mounted up out of the way, so that would be Y, I suspect. Yeah, I think that would be the Y. The other one would be the X, although technically it doesn't really matter. And so all these, including this one, will be behind this bulkhead. Once insulated, all this can be kept at a all the stepper motors will be able to be kept at a cool temperature, or definitely a cooler temperature than what's going to be in here. This enclosure I'm expecting to get up to 100 degrees C. I don't know what this one goes up to. I can't see anything on there. I will have another bit of a look later, but yeah, so 100 degrees C in the chamber. Most of this will cope with it. The only thing I'm slightly concerned of is these internal bearings here. I'm not sure if they will like being sat in 100 degrees for any length of time, which is why I possibly will extend the whole bulkhead. And this is just a carrier for the platform at the moment, so it's not intended to be in the heat zone. The main actual printing bed will probably start somewhere here, and we'll move across. So, and this motor stepper will be the other side, out of the way. Yeah, so a thermal barrier, but as a bulkhead, and it really does. It's made it very sturdy just by adding the square plate, really. And yeah, so that's where I am. So that's it with these linears. They turned out okay. They're not great, but they will do for now. This is okay. This is geared down with a 20 and a 40, so 2 to 1. No micro stepping, so no micro stepping on the board. It's exactly 200 steps per rev on the stepper, but obviously gearing it down means it's 400 steps per rev, and the lead screw is 2mm pitch, so 2mm per rev. So there's a fair amount of resolution there, and obviously I've got full scope of increasing the stepper micro stepping, so yeah, plenty of extra resolution and accuracy to be gained later on. I may change these for a proper ball screw, but I have sort of put this under some stress and tested it fairly well with just a DTI. This isn't the best quality DTI, it's just a tool zone thing, very cheap off eBay, but 0.01 accuracy, so they say. But it's more than accurate enough to actually test this slide, which I have done up and down and in the spots that were quite tight on these linears with the bearings, and no, it's absolutely fine, and extremely accurate as well. So I've driven it all the way up and down and it comes back to exactly the right place. It stays level, there's virtually no twist or give or any movement anywhere. This is a piece of 5mm plate basically, and just drilled, clearance drills, reasonably tight. These bearings from China, the holes are not exact, that's why these are not countersunk, because that's fine, I could match the holes up per this bearing, but if ever I had an issue, taking the whole bearing off means then you're without a printer. Whereas if there is a problem with the bearing, I can take one off, and at the same time I've got it all apart, I can drop another one straight back on and sort the damaged bearing out, and the printer's still in action. So I haven't countersunk them, just purely for the fact I can swap bearings easily without any alignment problems. This was fine, I can countersink this because obviously I drilled two pieces, the two components together, but the same again there, button screws with clearance holes. But no, this works out really well for now. Only testing later on will prove its worth. So that will be obviously another video once I've moved on a bit. Back to the control board a little bit. I have got these other stepper drivers, or micro stepper, off eBay from China. 4 weeks delivery. £6.50, but 32 micro stepping. Yeah, so I might try these just to see if there is any performance improvement with this. This absolutely works okay at the moment. Set up at 0.8 of an amp. Let's get Prontoface up. Prontoface is what I'm using just to communicate and set this up. I think everybody uses this to start off with, and yeah, so I'm just gonna go up 10mm. I haven't got any limit switches on at the moment, so I need to be reasonably careful, and this quite a lot of torque is generated via that NEMA 17 and that gearing and the lead screw, and it can really I have bound it up once already, and yeah, it didn't like it. So let's have a go. So that's up. And this is by no means finished or anything at the moment. This is probably still some speed to be gained, but this doesn't need to move that fast. So at the moment I'm just going down in increments of 10. Unfortunately it's just homed. I've only just switched this on and it thinks it's home. So I'm going to reset the printer. That's the problem, not having any limit switches on at the moment. Right, I'm going to have to set it home quickly. Here are the limit switches, just not attached to these. I probably won't be using these, purely on the temperature issue. If the chamber is going to be up to 100 odd degrees, that's down, 100 odd degrees, then I do not. Oh no, I want up. Silly. Yeah, no, I do not really want these in that zone, which is why I'll either use something else, which I've already got in mind. Some IFM proximity switches, IGT 203 IFM, 100 degrees C rated, so not a problem in my heated zone. Very reliable, non-contact, and yeah, a lot more reliable than these cheap things. I mean, I'm not saying, you know, limit switches aren't reliable, or these type of miniature limit switches, but at probably 50-60 degrees plus in an environment, they're not going to like it for too long, that's for sure. So they probably won't be used. So right, I'm just going to quickly, actually, if I place the camera there again, right, I'm going to hopefully move this up but hit the limit switch so it homes. That's the theory. I think that homed, and that did actually slip then. Hasn't done that before. So yeah, that's 1 mil, probably barely visible on the camera. That's 0.1. This is just temporary, just to check it really. So yeah, so that's 0.1 of a mil. Like I say, no micro stepping. 1 mil. Oh, and it slipped again. I think I need a little bit more current there. Not good. It's ice cold. Yeah, I think the current's about, yeah, it's 0.8 of an amp. That's what I set it at. And I've got a scope to improve. That's only 1.5 amp. This is rated for 1.5 amps, these NEMA 17s. So yeah, a little bit more current would probably help there. It wasn't doing that earlier, and I had this up to 1700. So why it's doing it today, possibly because I was running it for several hours, and over the time it lubricated the bearing, and I haven't run this at all today. I've just started this video more than anything, and that's the first time it's been run. So maybe they've just dried off a bit. My flat is very hot, and yeah, that one's bone dry. But that shouldn't slip anyway. The idea of this is not to slip. The idea is to be very accurate and not miss a step. Obviously, if you miss steps, then you're going to run into problems, and I do not want to run into added problems that I can engineer out. So, you know, I will make sure this will not slip. I mean, I can turn this by hand and fight the torque, the holding torque. Yeah, I think I can go up a bit more current than that, because that's not, should be able to do that really. So that's about it. That's where I am. There's a part of a bulkhead, the first part of the Z slide in place, and the next bit to do, which will hopefully come this weekend. Probably we will be using these proximity switches. I have got some laser stuff, laser optics, several photocells and other limit switches, but I think the fact these are rated for 100 degrees C, and I know these last forever as long as you don't smash them to pieces with your carriage or whatever. These last an extremely long time and are very accurate, especially these ones. These are a 10mm range. That's 10mm on steel, cut down obviously on aluminium and other materials. It's 0.4 of that, so it's only 4mm for aluminium. It's pretty about 6mm I think for brass, and 8mm for stainless steel, which is possibly what I might use. I don't know. Steel, if it's coated or something, or protected so it doesn't corrode, because this at the moment, that's stainless steel. This is hardened steel and will be lubricated. Everything else is aluminium and been anodized. So yeah, at the moment there's nowhere that corrosion can start. And yeah, whatever I use for the actual flag for this, I will make out of something that won't corrode. Probably stainless steel, I suspect. And this will be out of the way somewhere on an adjustable bracket, probably with an adjuster up here somewhere, out of the way but easy to get to, just to fine tune it. So I suspect I'll fix the sensor and the cable, bury it in the insulation and hide it out of the way so that it can't get caught and damaged, but which will make it so it's easy accessible if there is a problem with it. But I will make that probably fixed and rigid, and actually make the flag for the carriage movable. So yeah, actually I'm thinking it won't be up here, it'll be, if I put the flag on the carriage somewhere here, you could have a simple adjusting screw, thumb screw, just to move the flag up and down in small amounts and get your point just right. Yeah, a bit more thought on that at the moment, but so that's probably what we will be using as opposed to the conventional limit switches. I have noticed a problem with these as well. They do glitch. Marlin, I've had a quick look in Marlin to see if anything, and I can't see anything. That's the reason why. But anyway, I'm gonna have to go because that's my dinner. So hopefully next video a bit more done and a bit more explained. But yeah, overall goal is miles away at the minute, but I've got something. So we'll speak soon. Bye bye.